Thank you for taking the time to watch this video. So for this one, we are going to tackle about special products. But what is a special product? It's just a way wherein sometimes we don't use the fall method when we see a particular problem wherein we can solve it using a shortcut. Now, for this first example, let's have this one. So we have here a case wherein we have what you call the square of a binomial. A square of a binomial is in the form wherein if we have the same terms wherein a and b and you are squaring them, it's either a plus b or a minus b is equal to the square of the first term plus or minus depending on the given. We multiply 2 times a and b, or 2 times the first term times the second term, and then we add the square of the last term. Now particularly, why is the last thing positive even though we have a negative if one of the example? Now remember the concept wherein if we square a negative number, negative times negative is equal to positive, so that's the last term. If we square it, whatever happens is gonna be positive, may it be positive or negative. So now let's have this first example. We have here 5x plus 4. So if we want to solve this, we get the first term 5x, so we enclose that in a parentheses 5x squared plus 2 times the first term being 5x, and then the second term being 4, and then the last term being 4, and enclose that and square this. Now let's try to simplify everything. What is 5 squared? 5 squared is 25. X squared is x squared, of course, I just mentioned it. Now, for this particular problem, let's try to multiply first the numerical coefficients. So 2 times 5 is 10, times 4 is 20, and then we have the variable x. And last but certainly not the least, we square 4, which is 16. Thus, we are done with this problem. Easy, right? Now, let's have the second one. So that we won't be confused, let's have this. I oftenly do this wherein I already put the template in wherein we square this first term here, we multiply 2 and first and second, and then we square the last one. The first one, I write 3m here. And I'll also write 3m here because we multiply the first term and the second term. And then I multiply it with the second term being negative 2. And then negative 2. Simplify. 3 squared, 9. M squared, M squared. But let me not put plus yet. What is 2 plus times 3? 6. But times negative 2 is gonna be negative 12. And then we retain the variable m, and then we square the last term, but negative 2 squared is gonna be positive 4. It's still easy, right? You can pause this video if you want to work on this on your own. Once you do so, let's check if your answer is correct. Thus, let's square the first term in negative 4p, and then we add 2 multiplied by this first term times the second term, and then we square the last term. Now let's check. Negative 4 squared positive 16, p squared. 2 times negative 4 is negative 8 times 3, negative 24, and then we maintain p, and then we square the last term being 9. Last but certainly not the least, we square the first term being negative 3y squared, and then we add 2 times the first term times the second term, and then we square the last term. Now let's see. Negative 3 squared is positive 9, and then we write y squared, and then 2 times negative 3 is negative 6, but times negative 1 is positive 6. We maintain y, and then the square of the last term being positive 1. So the first one is pretty simple and on the get-go, right? And with that, Let's move on to the second concept. Now, we are going to have the square of a trinomial. If we have a square of a trinomial wherein we have three terms a, b, and c respectively, or a plus b plus c depending on what given, if we get the square of this one, all we need to do is we get the square of the first term plus the square of the second term plus the square of the third term. Now, we are not done with this. What we need to do now is we do the combinatorics wherein we need to pair a, b, and c into 2, wherein we all use these without repeating anything. So with this in mind, if I put them into 2 pairs, or rather into 2, we will have the pairs a and b, a and c, and then b and c. And what we need to do to these three are just multiply them to 2, thus having plus 2 times a times b plus 2 times a times c plus 2 times b times c. In this particular cases, all of the givens are positive, so we just maintain everything. A squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. Now let's try to solve this using these givens. So if we have here, again, we do the following. Square the first term, square the second term, square the third term. Then we do the following. 2 times the first term and the second term plus 2 times the first term times the third term, and then 2 times the second term and the third term. Now what you just need to do is simplify. If we simplify this, we will have x squared plus 9y squared plus 25c squared plus 2 times 3, 6, x times y, xy, plus 2 times 5, 10, x times c, xc, 2 times 3, 6 times 5 is 30, y times z, yz. Done. Simple as that. For the third and fourth example, I'm gonna leave that as an exercise. So let's have example number 2 just in case. Again, first step, we square the first term, and then we square the second term, and then we square the third term, and then we multiply 2 times the first term times the second term, and then we multiply 2 times the first term times the third term, and lastly we multiply, or rather add 2 times negative the first term, no, not the first term, sorry, 2 times the second term times the third term. Now simplify. Negative 2 squared, 4, x squared, y squared is the y squared, 4 squared is 16, z is c squared. And then for this one, we have negative 4, and then maintain xy. And then we do the same for these ones. Negative 16, xz, and then 2 times 4 is 8, yz. Simple. Do these two others. Pause the video if you want to learn more or analyze what just happened, and then just solve it. The third example, in which I didn't have an example but I will give one by myself, is the product of the sum and difference. It's the easiest among the three. Product of the sum and difference is just having these two wherein we have x plus y, or rather the sum of two terms x and y, and then we multiply it to x minus y, the difference of the two terms. It's just simply getting the square of the two terms and then just putting minus in between. Let's say I have example 1. Let's say I have 2x plus 3 and then 2x minus 3. It's just I simply get the square of 2x minus the square of the square of 3. If I simplify this is 4x squared minus 9. Simple as that. Number 2, I have 1/2 x plus 2/3 y, and then 1/2 x minus 2/3 y. It's just simply getting 1/2 x quantity squared minus 2/3 y quantity squared. If I square 1/2, it's just simply 1/2 times 1/2. 1/2 times 1/2 is 1/4. And then square x minus 2 times 2 is 4. And then 3 times 3 is 9. And then y times y is y squared. Simple as that. And the last example that I need to give more focus on is this one. So pause the video if you need some break. And I will cut this here. Thank you, Kenza, for the hydrate. Let me hydrate actually. I need it. Thank you so much. Chat, so how is the lecture so far? Okay, I'm back. Why is it always occurring wherein whenever it's exam season, I don't have a voice? Wait, let me adjust this real quick. There you go. Oopsie. Okay. We're resuming the lecture in 3, 2. Okay, now. Suppose this is the fourth part that is included in your exam. We will have the last part, which is the cube of a binomial. A cube of a binomial consists of the following steps. If you have two terms a and b, what you need to do here are the following steps. I suggest that you already put the parentheses on this one, but the first and foremost, we cube the first term, in which the first term is a, so we cube a, and then plus 3 times the square of the first term a, and then we multiply the second term. Next is that we add 3 times just the first term, but this time the square of the second term. So we are alternating, in which we have squared the first term. On this one, we need to square the second term. And what's missing now is the last one, wherein we have to cube the second term. If we simplify this is just simply a cubed plus 3a squared b plus 3ab squared plus b cubed. I think I already answered problem number 1. But this time it's minus. Let's check what will happen if it's minus. So if we do this, this is gonna be the square of the first term, which is 3. We have no problem. A cube rather. Sorry. A cube. But here's the thing. The first term BA, or rather the few step is we add 3 times the square of the first term times the second term being negative b. And we add 3 times just the first term, but this time we squared the second term, negative b, and then we add the cube of the second term. Let's simplify this. If we do so, it's gonna be a cube plus, or rather, let's check if it's plus. A squared is a squared, but a squared times 3 is 3, but we have here negative, so it's gonna be negative 3a squared b. So we have noticed that the sign still differs on what is our given. So be careful. Now, but on this particular part, if we square a negative number, it's going to be positive. So this is guaranteed positive, 3ab squared. But if we get the cube of a negative, it looks something like negative times negative times negative. We know this is positive. But what is positive times negative? The answer is negative. Thus, it's minus b cubed. Okay. Let's have this second one. So, again, what I suggest here is just you put already the template. If you know, b cube the first term, we multiply 3 and the square of the first term times second term. And then we multiply 3 and then just the first term, but we square the second term. And then we cube the last term. Write all the first terms that we have. First term here, first term here. And the rest that doesn't have anything here is the second term. And now we simplify. Let's have this. Y cubed. Square of y is y squared. And then we have 3 times 3, which is 9. 9y squared. 3 squared here is 9. 9 times 3 is 27. And we have y. And again, 3 times 3 times 3, or 3 cubed is 27. Simple as that. Let's have this third problem. Wherein again, I suggest that you do the template. Just cube the first term, 3 times square the first term and the second term, plus 3 times the first term times the second term squared, plus the cube of the third term. So put all that has the first terms here like this, and the second term on the remaining ones like here. Now, if we do so, we will have x cubed. 3 times negative 5 is negative 15. X squared, like here. 5 squared is 25 times 3 is 75. X. And then we get 5 cubed, which is minus 125. Last number. For the last number, again, it's much easier if we do the template first. This, square the first term, then second term. And then 3 times first term times the second term squared. And then we cube the last term. Write all the inside the parentheses all the first terms that we need to, like here, and the second term right here. And then simplify. 5 cubed rather is 125, and then x cubed. And then 5 squared is 25. 25 times 3 is 75. 75 times 3 is, if I remember correctly, 75 times 3 is equal to 225. I will correct this in a future note if I get this wrong. So 225 x squared y, because of this one, squared, and then we need to multiply y. Next, we square 3, which is 9. 9 times 3, 27. 27 times 5 is 135. Oh yeah, it's 135. 125xy squared. We have x here, we have the square of y. And then we cube the last term. 3 times 3 times 3, 27, and then y cube. And I think that's it for a brief review. If you want to study more, there are a lot of information on the internet, and you can just ask me for some questions. And with that, thank you for watching this video. Good luck on your test.